Im Bereich der Erklärbarkeit wird eben an Methoden geforscht, die dabei helfen sollen, den Input, der Dateninput eben in Verbindung zu dem Output, dem Ergebnis eines KI-Modells zu setzen und dadurch eben herauszufinden, welche Inputdaten besonders wichtig sind für welche Ergebnisse und dadurch eben auch eine Chance wahrzunehmen, Fehler zu erkennen und ja, dieser Ansatz oder diese Ansätze sind eben daraus entstanden, dass EntwicklerInnen ihre eigenen Modelle und Systeme besser verstehen möchten und eben auch die Vorgehensweisen oder theoretische Konzepte dazu entwickeln wollten. Und auch da finde ich ein Beispiel ganz anschaulich, dass eben bei einem Bilderkennungsverfahren, das eben ein Boot als solches klassifiziert hat, die Pixel des Wassers als besonders bedeutsam bewertet hat und damit natürlich ein Boot zum Beispiel an Land nicht erkennen konnte, was dann ein Fehler ist, den zu kennen, das ist hilfreich. Aber es gibt eben auch so ein Beispiel, das mir Professor Samek mal erzählt hat, der unter anderem an der TU Berlin forscht, eben zur Erklärbarkeit. Und dazu haben wir uns ausgetauscht und hat mir dann auch ein interessantes Beispiel genannt, das er mal wieder in Vorträgen anbringt, wo er eben einen Altersklassifikator, sage ich jetzt mal, entwickelt hat, mithilfe dessen das Alter geschätzt werden sollte von abgebildeten Personen und eben darstellen sollte, welche Pixel besonders bedeutsam sind. Und für die Klassifikation als jung waren die Pixel um den Mundbereich eben sehr, sehr bedeutend bei einer lächelnden jungen Frau und bei einer älteren lächelnden Frau wurden die als Gegenanzeichen gewertet für die Klassifikation als alt. Und daraus hat er eben geschlossen, dass dieses Modell das Muster erkannt hat, dass junge Menschen öfter lächeln. Und er wurde dann eben häufig gefragt, ob das nicht auch sein könnte, dass es an der Farbe der Zähne zum Beispiel liegt.
What we do is look into really open up the black box and say which are the most important parts in that black box which actually played a role. So if you look at models such as which really do back some relevance propagation really within deep neural networks, for example, they really just ask which portion of the network were the most relevant at the moment at which the output for X was for the input, which we commonly call X, when that output was computed. Learning models really are large neural networks with a lot of layers. And what we are commonly interested in is given an input. So you can imagine an input as living in a particular landscape, right? So really in a large scale function space. You look at that particular point, you look at the surroundings of that point, depending on the model that you use, and you really say which of the features of this X were the most important in taking the decision that I took, right? And that's commonly what you communicate to the end user. There are different ways of computing that, but that's a general idea. Another family would actually just say, looking at the neural network in and of itself, which parts within the neural network were the most important, but technically leads to roughly the same thing. And we then take those features and tell the user these were the most important features which led to the classification. But importantly, those are not the only types of models. So we do have white box models, so what we call anti-hoc explainable machine learning models. And those are the type of models which I am most particularly interested in, simply because when one uses anti-hoc explainable models, one has the ability not only to explain the output of the model, but actually explain how the machine learning process led to that particular model. And that's basically quite a significant advantage of those model types of that particular family. So I would say deep learning is not necessarily the way to go for all types of applications. And for such critical applications, especially where humans are involved, I would refrain from using black box models are not strongly such as using white box models. So decision trees is kind of the prototypical white box model, but the inference power of a decision tree is not necessarily where we want it to be. But there are other significantly stronger models, which are still white box models. So models based on description logics, for example, which can express way more than a decision tree, but are still such that one totally understands why the model takes a decision and which features are used and so on and so forth. The reason why a deep neural network is so hard to explain is that most commonly you deal with feature vectors and with input vectors, and those input vectors are very long. Most humans have a problem thinking about 4-dimensional space. Imagine having to think about 1,000-dimensional space. It simply doesn't work for humans. Humans don't think like that. But that's basically the types of spaces in which deep neural networks operate, which means bridging from a function in 1,000-dimensional space to human thinking is simply very difficult. While structured data is such that it's tabular data or graph data or the like, and the models, which are so basically white box models, really simply reuse that structure. Those structures are most commonly created by humans, which basically means that humans actually understand those structures and hence understand how the decision is taken and generated. What is it that I'm trying to explain? That is a very good question. There are two things that we are most commonly interested in explaining. Number one is the outcome of a particular model. Ergo, if you assume that model is a function, we try to explain how that function computed the output y given the input x. And then for particular applications, for very specific applications, especially applications which have to do with engineering, for example, we also try to explain how the model came about. So which were the steps from the training data up to the model. But that is a definition of explanation which is rarely used. It's more for very specialized applications. And the way we explain is really what varies. So currently in my research area, we are concerned with 3 main types of explanations. We either try to verbalize a model directly, so create a natural language representation of what the model does. We also have counterfactual explanations, where we aim to explain what features would have had to change for the classification in and of itself to change as well. And we also spend time thinking about justifications, ergo, which is the minimal set of or subset of the data which led to that particular conclusion, ergo to that particular classification. And that obviously can be verbalized as well. So counterfactuals and justifications, actually all 3 are not tailored towards machine learners. That's the whole point. That's why I think that's so interesting, because they are in natural language. They describe data in general, or basically axioms on data, but in a language which professionals, basically not end users, not professionals, end users, which are commonly professionals on the input data, actually understand. So if you think about a banking application, for example, you will know what things like your income or the place where you live, or basically your current loan rate, those things you will know, and you will understand those terms. But those are exactly the features which we'll then use to run the classification. So it means that the end user would actually understand the text that we generate without having to have any form of expertise in machine learning. So if you consider any classification or regression task which affects a human directly, and I think that's also what the GDPR really foresees already, I think there is an intrinsic need for explanations, and we should be able to deliver such explanations. The area where I think, or there are some areas where explanations are simply really not necessary. If you think about an IoT model basically deciding whether a machine should go left or right, and that basically doesn't really influence a human. Well, basically what you're interested in is throughput performance there. Who cares about an explanation? Maybe the end technician, but the end technician can't really deal with feature vectors, then it's fine.
Also wünschenswert ist Erklärbarkeit eigentlich in sehr vielen Kontexten, würde ich sagen, ne? Besonders aber dann, wenn sie das Wohl von uns Menschen oder auch des gesellschaftlichen Zusammenhalts betrifft. In Kombination eben auch mit anderen Maßnahmen wie Dokumentationspflichten und ja, bestimmten Prüfprozessen auch. Ja, und insbesondere dann eben, wenn sie fundamentale Rechte oder Grundrechte betreffen, wenn ja, auch Gesundheit oder wichtige Sicherheitsaspekte betroffen sind.